So hello everyone. Look at this player movement. You might not see any problems with it, and well, that's because there aren't any. So let's improve it with Juice. Game Juice, also known as Game Feel, is a polishing step where you add extra audio and visual feedback to any feature of your game. Or at least that's how I would describe it. This can range from small things like minor animations of UI buttons to insane explosions and particle effects that completely blind you. Anyways, we have a nice base movement system right now with basically no juice whatsoever. Let's try spicing it up. We will go from simplest to the most complex one. The easiest thing we can add is some jump particles. The way I did it is quite simple. The particles spawn in all at the same time on a line with a direction facing upwards with 45 degrees of spread. They have a short lifetime and some initial velocity. The scale is randomized and goes down based on lifetime to have some sort of fade out effect. Next one is some wall-climbing particles. These are literally the same as the jump particles, except they have a constant spawn rate and they are rotated to work with the wall. The way to activate these was quite simple with my movement system, as I already have a variable that contains the wall angle, so I can just use that to enable the correct particles. Okay, let's do something more complicated. Currently the long jumps and spring jumps work by just adding more speed to the player. A nice way to spice this up would be to turn them into dash-like movements. My game works with limiting the max speed of the player, which makes this really easy to do. I have two variables, current max speed and target speed. When you long jump, current max speed will be set to a value larger than target max speed by about 6 times. After that, I add a large amount of velocity to the player. In the physics update, the current max speed will be smoothly lerped towards the target max speed. The faster the lerp time, the shorter the dash will be. I chose 10 times delta time. Now play around with these values until it looks good, and you should get something like this. I also added this to spring jumps in the meantime. This is how it looks. As you can see, it made the boring speed changes much more snappier, which I think looks and feels better. If we are already working on long jumps, let's add an extra effect to it. In my game, you can combine a long jump and a spring jump to get a chain jump. I want to add a ghosting effect to indicate if the player can perform a chain jump. To achieve this, I made a new script and added a function called sprite delay effect. We start by duplicating the player's sprite and moving it to the player's current position. Then we tween the alpha of the sprite to make it fade out. This code gets repeated multiple times with a delay in between to create the desired effect. When the loop ends, we wait a bit more before deleting the objects to free up memory. Now we can call this function to create this ghosting effect. Nice! Now let's do the most complicated one, an impact. I wanted to add an epic impact whenever the player performs a chain jump to let them know they did it correctly. This effect has many layers, so let's start by adding them one by one. First, I added a large white square particle to function as a flash. During the particle's lifetime, the player turns black for added epicness. I did the color change in code by setting the color modulation of the sprite. Next, I made some contracting lines that change angle based on which way you chain jump. These are just some non-moving particles that spawn on a line with a fully white texture that has a size of 2 by 32 pixels. Over time, these particles slowly scale down to 0 until they disappear. The angle is calculated with this short piece of code here. I had to modify the particle spawn angle since modifying the rotation only works if the particles are in local space, and I wanted to use world space instead. I also added a very minor effect, which is this short transparent trail that's affected by gravity. It sort of looks like a burning effect or something, and I thought it looks cool, so I kept it. The last effect to finish it off is a Distortion Shader. Using a radial gradient that goes from white to black from the center and with a bit of coding magic, I managed to make a lens distortion effect. Now I animate the scale and intensity of it in an animation player, and it's ready to be used. I also added this effect to both the long jump and spring jump because it just looks so cool. Alright, we are finally done with effects. But something is still missing, right? Yes, the camera is still static, so let's change that. The first and kind of obvious thing to add is Screenshake, but if you just slap on a Screenshake script, keep in mind that it can also be juiced up by using Directional Screenshake. Directional Screenshake is when you apply shake in a direction instead of randomly on all axes. This makes the screen shake feel more like it's coming from the player's movement rather than just a bunch of noise. To do this, take any screen shake implementation and multiply the camera offset value with a vector direction. My screen shake is based on this video I found on YouTube by Pefper, where I modified the output to work with the direction and applied it to the camera's offset instead of its position, as the position gets overwritten by the player follow script. I also made a function that sets a target direction, which I use to smooth lerp the current direction to. I did this to avoid some unwanted jitter in the screen shake when the direction changes. I added this screen shake to every type of boost jump and it immediately looks better. After screen shake, we can still add more camera movement to make it even more dynamic. I wanted the player's velocity to influence the camera as well. The way I achieved this is by creating a new script and calculating the offset with this code. I had to clamp the X velocity because long jumps create a huge amount of velocity for a few frames, which causes the camera to jitter. At the end, I set the camera offset with a smooth lerp that lerps between 0 and the offset. This lerp is there to make sure the camera returns to the center when the player stops moving. There's one more effect I want to talk about, and it's slow motion, but more importantly Hitstop. You can think of Hitstop as a more extreme version of slow motion, but basically it's an effect where the game freezes for a couple of frames and is often used to emphasize impacts, explosions and other powerful effects. It's relatively simple to add in Godot, as you can create a timer that works using real time instead of data time. Using that you can freeze timescale of the engine to create a very simple implementation. Originally I added this to all boost jumps, but the game felt too stuttery, so I just kept it for the chain jump explosion only. And so that's all I have currently. All of this is still work in progress, so I would love to hear how you'd improve it further. See ya!